The Montana Department of Transportation is responsible for more than 400 timber bridges built between 1925 and 1950.
Our climate is really benign, which means that our timber bridges generally last longer than a lot of other areas in the country. But we're also cursed in the fact that our timber bridges have lasted a lot longer than other areas in the country. So we're stuck with a infrastructure that consists of a lot of timber bridges that are very old, and a lot of times they're still in very good shape except for one or two girders or one or two piles or a cap or just a couple of elements.
Fiber-reinforced polymer offers an economical solution for strengthening and repairing individual bridge components.
So fiber-reinforced polymer, FRP, is basically very strong fibers that are then held together by some sort of matrix material. In this case, polymer, a strong plastic, essentially. And so we've got different types of fibers that you can have in FRP. Glass and carbon are very common, GFRP or CFRP. And so specifically for this project, we've been using glass FRP channels. So we're looking at using the channel sections to essentially attach to the sides of these timber girders in order to increase our flexural capacities, as well as our shear capacities, depending on where we're at along the girder.
In the laboratory, researchers have conducted a variety of stress tests on beams that have been repaired with FRP, and the results have exceeded their expectations.
The coolest thing we found so far after doing all of our structural testing in the lab is that we can almost completely destroy a beam, sew it back together, put this material on there, and then retest it and get 50% higher loads than what originally took to break the member.
With such promising results, MDT is already looking at ways it can put this technology into practice.
So the next step in the project is to find a couple of bridges that we can go out and implement this material in the real world. Doing something in the lab is a little bit different than doing it in real life, but this is a pretty simple process, and we think it's going to translate very well to real world application.
Learn more about the project on MDT's website.